So in this video, we'll quickly look at support vector machines. Support vector machines is another way of classifying, just the way we looked at decision tree, random forest, as well as logistics regression. So what we're doing here is we are using the E107 package, and we're basically creating a model using support vector machines. In this case, we may also have to use Kernel. Kernel is again a way to identify proximity to a given set of known entities or landmarks. So essentially what we're doing is we're choosing the kernel type. The default is radial in some cases. In this case I've specified the value as radial, but it could be linear if you don't have to use a specific proximity calculation. So this type depends. It can be another value could be RF dot. So I was taking radial, and then I'm specifying the constants gamma and epsilon. Now these can be arbitrary values, or you could use tuning. So that's basically covered in the performance tuning. So there's a function called best.svm. So I'm quickly running this because I don't know the value of constants in advance. I would just quickly run the best svm to get me the right sort of values. So it will compute the values and it will tell me what those values are. And once I have that, I will input that into the SVM modeling tool. So for example, I'm using the cost as 1. This is the penalty for misclassification. And then similarly, I'm specifying the values of gamma and epsilon, which gets plugged into the formula for SVM modeling. I'm choosing kernel method as radial, and you can see here once it runs the optimization, it gives me the gamma value is 0.05 and epsilon is 0.1, cost is 1, and I'm plugging those values here. So once I run this, it will get trained on the training data set. So data is trained, and then I would use the predict command, excluding the output, and then I can get the values of 0 or 1, which is basically the person being grade worthy or unworthy. And then I can plug this back into my data frame, and the rest is similar. So basically you have compute performance objects, and then I would do an ROC analysis. So a quick way to do this is use the confusion matrix, and it can get us the values of various evaluation metrics such as sensitivity, specificity, accuracy, and so on.